Hello students, welcome back to one more session of your WOC. This is your Vani ma'am back again with one most important session for your term 2. Right. Thank you all students for your cooperation. Yes. Welcome to all the new students who are joined the platform. This is a warm welcome from your Vani ma'am. And for all the students who have been associated with the channel, thank you. A wonderful gratitude from my end. Yes. So today what are we going to learn? We are going to learn the complete nomenclature of coordination compounds. Yes, you all know students, term 2, your coordination compounds is the most important chapter. Compulsory one question would come from your IUPAC nomenclature. So we are going to see the complete video step by step. I'm going to explain you the rules. I'm going to explain you the examples. I'll show you how to calculate the oxidation number. What are the important things you have to remember for your exam? At the end of the video, you will have a complete understanding of the concept. And my request, please share the video to all your friends. Yes, please comment whatever you have felt after watching the video, and important, please like the video. Okay, right, let us start off students. My request, please watch the complete video so that you will have a clear understanding of the topic. All right, so before starting, we are going to see the IUPAC nomenclature rules, right? So what is the nomenclature? What are the rules? We are going to follow the latest latest rules which are prescribed by your IUPAC. Yes, students. So you can directly apply that in the exam and get marks, right? So let's start. So first of all, important before I start, I have done complete coordination compounds chapter. Complete coordination chapter, that too line by line of NCRT, right students? Complete coordination chapter, and that too line by line. Okay, line by line of NCRT is done from my end, so it is kept in the playlist. Please check. Yes, a detailed video is there which you can go through the whole chapter. Detailed video, everything is kept in the playlist. Yes, so the link would be given in the description for this chapter. Please go through the link also. Let's start off without wasting time. Okay. So first important thing, students, whenever you're learning IUPAC nomenclature of coordination compound, rule number 1, 2, always remember. Yes, students, what is it? See, you we very well know coordination compounds is always, or if I have to take a complex compounds. Okay, you are going to write the coordination compound. You're going to represent one in the coordination sphere, correct? There will be a metal, there will be a ligand inside this, and there will be certain coordination number, for example, 6, and you may have an ion here or you may have an ion here, correct? Suppose if you have a ligand here, let us assume there's one more ligand here. It is outside the coordination sphere. Rule number 1 is always start naming from here. Let us take one example. For example, there is one complex like this, PtCl6. First, we will see the rules and then we will go to the example. So here potassium is outside. So you have to start naming the complex as, start it as potassium. Okay, right? And the remaining complex name, I'll be teaching you how to do it. So first start with potassium name and then you go with the remaining whatever is there and end your answer. This is rule number 1, students, remember. So if it is here, if the ion is here, you will name it at the end. If it is before, you're going to name it at the first. Yes, students, remember that. Next important rule which we are going to learn is careful. Rule number 2 is you have 3 types of ligands. One are anionic ligand is one, correct? Cationic ligand is the second type of it. And the third type is neutral ligand. Correct, students? You have 3 types: anionic ligand, cationic ligand, and neutral ligands. For example, if I take an anionic ligand, for example, like your chloride, bromide, example, iodide, cyano, right? So what do? You are going to name the anionic ligand as, okay, this is chloride, na? Yes. So what are you going to do? IDE is substituted by O, chlorido. Okay, I'll show you the examples also. Chlorido, bromido, iodo, right? So, right, iodide also we can name it. So, you're going to use it O as well. Got it, students? One more important thing to remember, see here, IDE is substituted by O. ITE is substituted by ITO. Remember. Next, ATE is substituted by ATO. Okay, students, remember that. But cyano, remember, we are going to write the cyano as cyanide only directly. No change in this. So this is for your anionic ligands. Okay. Let us go for your cationic and neutral ligands. Suppose rule number 3 is if you have your neutral ligands, let me take that neutral ligands. So neutral ligands are different series of neutral ligands, correct? For example, like water, like ammonia, like CO, like NO, like the methylamine, like pyridine. All these are different examples of neutral ligands. So for them, you will be having the same, almost the name will not change. It will be the same. For example, aqua, you will be using aqua. Okay, you will be using amine. This is carbonyl. Same name would be there for neutral ligands, right? If I take NO, it is called a nitrosyl. Okay. If I take this, same name would be there. That is methylamine. Okay. Then comes pyridine. So there is no change in name. So for neutral ligands, remember, you'll always take the same name. There won't be any change in the name like anionic. Okay, and important thing, students, whenever you are doing cationic also, I'm going to show you the examples further. Suppose if you have any chelate ligands, like rule number 3 is chelate ligands. So chelate ligands means, bridging ligands, correct na? So chelate ligands are also called as bridging ligands. So when you have bridging ligands, I'll be showing one example. Please watch the video till the end. You're going to use a prefix. Yes, you're going to use a prefix like bis. Will start like tris. If there are two ends, two sides, bis. Three sides, tris. If there are four sides, tetrakis. Like that as a prefix before naming. So remember all these rules. I'll be giving you the examples lot. We are going to do almost 40 examples today. Okay. Now next important thing, let us take one more rule. Important rule number 4 is whenever ligands are there, please name ligands according to alphabetical order. So let us write the rule. Name ligands according to alphabetical order. Alphabetical order. Okay, right order. For example, let us take one example and see. I have one complex with me, NiNH3 taken twice, CO taken twice. It is given by your teacher. So here, this is A, na? This is A, this is C. So how do you start naming? You start from the ligand. How many are there? 2 are there. So it is diamine. Then comes dicarbonyl, correct? And both are neutral ligands. That's why there is no oxidation state, nickel 0. Nickel 0. That means please follow the alphabetical order while naming it. Okay, right. And next important rule to remember is rule number 5 to remember is suppose if you have a ligand, a complex, let us take one example. This is a complex like this. This is ammonia complex. Okay? Then here, what should you do? You have to first calculate the oxidation state. Remember that. So check or calculate oxidation number. Oxidation number. How to do it? So oxidation number is simple. You're going to calculate oxidation number of which one? This is metal, ligand, ligand. You will calculate oxidation number of central metal. Okay, so what will you do? You'll put X for platinum, that is a metal, plus 4 into 0 because it is a neutral ligand, plus chlorine is how much? 2. What is a charge on chlorine? -1 is equal to +2. How much is X equal to? X is equal to 4, my students. Yes. So now name the compound. Start from ligand. It is called as tetraamine because it is neutral ligand. No name change in the name. Correct. C stands for it's a negative ligand, so it is chlorido. Yes. So this is platinum. 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 What is the oxidation number? 4. Write it in Roman number complex. Okay. So what are you going to do? So always oxidation state is denoted by which one, students? Oxidation state you're going to say. So I'll take this. Okay. Oxidation state is always denoted by which one? By Roman numeral. Roman numeral. Is it okay? Right, numeral or Roman. All right, so before we start the complex, and I have forgot one thing, let me tell you. Suppose if there is a non-ionic complex, non-ionic complex means non-ion means it is a neutral molecule. Then what should you do? For example, nickel tetracarbonyl. This is non-ionic, no, it is neutral. So the same name is given and write it in one word. Tetracarbonyl, tetracarbonyl, nickel. There is no oxidation state, it is neutral, it is 0. Okay? Like that. Okay, remember these 5 rules, it is easy. Let's start. And metal atom, how are we going to name? How are we going to see? Let's see. See, students. These are the list of ligands which are negative in nature. So I have given you the names, how you should name it. Negative ligands with IDO, I said na, see here everywhere. So IDO, azido, like that. So these are the examples of the negative ligands where you're going to end it with your IDO. Suppose if you have your positive ligands, remember students, positive ligands or the cationic ligands are going to end with IUM, nitrosonium, nitronium, hydrazinium, like that. For neutral ligand, it is the same name. There is no change in the name of the ligand. Okay. Suppose if you have an metal in an anionic complex, then metals are always ending with ATE. Yes, aluminate, chromate, cobaltate, cuprate, aurate, like that. So metals with ATE. Got it, students? So please note it. Examples I have given, and let us start with almost 40 examples and let's name it. So watch the video till the end. Please share the video to all your friends. Share the video so that everybody can get values from this or educated from this. Let's start off. So this is the complex given to me. Step number 1, what should you do? You have to calculate the oxidation number. Yes, for the metal atom X plus. Now this is whole thing is a complex ion, my students. This is your complex ion. So in complex ion, okay. So once again, this aluminium is X. Now lithium is also +1, my students. Yes. So what will I do? I'm going to write this oxidation state. This is normally +1. So what will I do? First, I will write the inner ones. So aluminium hydride is 1 in this case. This is hydride ion. In a complex ion, this is hydride. So hydride is always denoted by H minus. How many are there now? 4 into -1. So this lithium is +1, right? So when it goes out, it will become -1. So X is equal to how much? It is 3. So name it, students. Start naming from here. I said rule number 1. First, you will write the ion which is outside, lithium. How many hydrides are there? Tetra. Hydrogen is negative, isn't it? So you're going to write it as hydrido. This is metal complex. So you will write it as aluminate. How much is the oxidation state? It is 3. Roman number 3, complex. Easy, students? Easy. Let us do one more now. Na3CO NO2 taken 6. Nothing to worry. Check the oxidation state. Here sodium, I can do like this also. Sodium, 3 are there into +1 plus X plus nitro NO2 is -1 oxidation state, which I've shown in the table. Make it equal to 0. So X is equal to how much? 3. Name now, start from here. Name it sodium. How many are there? Nitro, 6 are there. So hexa. And nitro means nitro. Okay. So it is attached to your metal atom using N. Here it is an ambidentate ligand. Now, students, ambidentate ligand means it can attack from both the sides. That's why you're going to take that as N. N. Then metal atom, cobaltate, yes. And what is oxidation state? 3. Complex. Easy. Let us do one more example like that. NaAuCN2. Oh, nothing to worry, easy, right? For this it is +1. Metal you don't know. X. Cyano is 2 into -1 is cyanide is equal to 0. X is equal to how much? 1. Name the compound now, students. It is, start from this, sodium. How many cyanos are there? Di. It is cyano. It is metal complex orate. How much is oxidation state? 1 complex. That's all easy. Next example. Yes, let's see. One more. Here again, sodium is there. Check the oxidation state. It is +2 plus zinc. How many chlorines are there? 4. What is the oxidation state? -1 is equal to 0. Name it sodium. Okay, right. Basically, disodium also I can write because 2 sodiums are there. Disodium, tetra, negative ion, chlorido. Then it is metal atom, zincate, 2. Zincate 2 complex. Okay, hi, if I got here, X is equal to 2, 2 complex. Easy. Easy. Yes, let us see like that one more example. Again, sodium is outside, so it is 3 plus X for metal 3. Now, important, this is your bidentate ligand. Correct now? Oxalate is a bidentate ligand. So, how many sites are there? 2 sites are there. Yes, so 3 into what is oxidation state? -2 is equal to 0. So, X is equal to 3. Write the name now. So sodium, disodium you wrote there. If you write like this also it is right, students. You can write sodium, no problem, it is right. Write oxalato because it is oxalic acid. How many? 3. 3 oxalato, right? It is ferrate 3 complex. Okay, done. Easy. Okay, now let us see one more. Potassium. Even if you don't write di also, tetra also, no problem. This is also right. Check the oxidation state. It is +4. Iron is +6. Plus 6 into -1 is 0. X is equal to 2. Name it. Now it is potassium. How many cyanos are there? Hexacyano. It is which complex? Ferrate. How much is the oxidation state? 2. 2 complex. Easy, students? Easy. One more we will see. Yes. See this. Okay. Now, this is a bidentate ligand. Note it carefully, bidentate ligand. So, how many sites are there? 2. 2 oxalic acid because oxalate ion, like it's like this. CO minus, COO minus. It is linking from both the sides to the metal atom. No? So, oxidation state, let us check. Potassium is 3 plus 1 into 3. So, +1 into 3 plus X plus oxal 3 minus 2 oxidation state 0. X is equal to 3. Name it. It is potassium trioxalato, negative ion, aluminate 3 complex. 3 complex. Easy? Easy. Let us see one more. This is a neutral ligand. Correct now, students? So this, when it is a neutral ligand, you should write the complete name in that. So calculate the oxidation state. X for metal, 0. 4 into 0 is equal to 0. Name the compound. It is tetracarbonyl nickel. There is no charge, so 0 complex. Easy? Let us see one more. Okay. Now silver. That is right. Let us calculate. This is, sorry, this is X plus. This is which one? Neutral ligand. Na? This is the neutral ligand. Ammonia is a neutral ligand. So what will we do? There is no charge. 2 into 0 plus minus 1. Chlorine is equal to 0. Now name it. Start from amine. Diamine. It is neutral ligand. So same name. Then silver. How much did we get? X is equal to 1 here. So silver 1 chloride. Easy, students? Easy. That's all. Nothing. Just two the things. Checking oxidation number. Writing the name of it. Let us see one more. Here you have platinum, ammonia, bromine. No problem. Let us calculate the oxidation state. First X. Ammonia is neutral ligand. Na? So 4 into 0 plus bromine are how many? 2. What is the charge? Minus 1 plus here bromine 2 into minus 1 is equal to 0. So how much is X? X is equal to 4. Name it. Start numbering alphabetical order. So the rule here is use alphabetical order. So how much do you get here? You're going to write it as tetraamine. Okay. How much is bromine? 2. Dibromido. Okay. Then comes your platinum. Then what is its oxidation state? 4. There is one more bromine outside. So you will write bromide. So the name is tetramine dibromido platinum 4 bromide. Correct? Next one. Let us see this. Nothing to get confused. So here it is ammonium is separately. There are two complexes here. Calculate the oxidation state. Ammonium ion is, yes, 2 into plus 1. Correct? Then platinum is X plus, this is thiocyanate, minus 1 oxidation state. 6 into minus 1 is equal to 0. X is equal to 4. Name it. Start naming ammonium. How many are there? 6 are there. So hexa. So it is thio group. It is thiocyanato. Negative ion, students. Nato. Then it is attaching the metal atom with S atom. That's why we call it as S platinate 4 complex, because the oxidation state is 4. You see, let us see one more. Like CO NH3 taken 6 times Cl3. Calculate. This is X plus. This is neutral ligand, students. Neutral ligand. So the oxidation state is 0. 6 into 0 plus 3 into minus 1 is equal to 0. X is equal to how much? 3. Name it. Hexa, because it is neutral ligand, same name, amine, cobalt, 3 chloride. Easy enough, students? Yes. Next one. C1H3 taken. Okay, there is a charge given. First, let us calculate. This is X. This is neutral ligand, ammonia, 0 plus. Chlorine is minus 1 only, is equal to plus 2. So X is equal to plus 3. Simple. Name it. Pentaamine, because it is pentaamino. Also you can write, that is negative ligand. So chlorido. Then comes cobalt. How much is this? 3. Now this is an ion. So you will end it as ion. If it is a complex, you write it as complex. If it is an ion, write it as ion. Okay, next one. Let us take this example and see. Okay, right. Calculate. This is X. This is neutral ligand. Nitro is -1 is equal to 0. X is equal to 3. Name it triamine. Okay, trinitrito. Now see students, nitro is attached to cobalt with N. This is an ambidentate ligand. So you should mention which site it is attacking. It is attaching from N, so N. Then cobalt 3 complex. Easy? Easy. Got it? So one more we'll see students. This is one more. There are a lot of ligands. Let us see. This is X. This is neutral ligand. So 0. This is also neutral ligand. 5 into 0. And iodine is 3 into -1 is equal to 0. X is equal to +3. Name the compound. This again you should follow alphabetical order. Careful. Ligand should follow alphabetical order only. So name it. So amine comes first. So pentaamine. Okay, right. Then water is neutral. Aqua. Then it is cobalt. Then it is 3. Cobalt 3. Iodide is outside. Iodide. Easy students? Easy. Now let us do one chelating ligand. So this is a chelate ligand. Chelate means bridging ligand. Here in dimethylamine, how many sites are there? Basically, it is NH2, CH2, CH2, NH2. So two sites are there. This is one site of attack. This is one more site of attack. So what? It is a neutral ligand. Though it is chelate, it is a neutral ligand. Because it is a neutral ligand, charge is 0. X plus 3 into 0 plus 3 into -1 is equal to 0. X is equal to +3. Name it. It is a chelate ligand, so we will use the prefix like bis, tris, tetrakis. How many are there? 3 are there, so you should use tris. See this? Start from tris, put goes a bracket, ethane. It is ethane 1,2-diamine. So ethane 1,2 diamine. Diamine. What is the metal ion? Cobalt. How much is it? Cobalt 3 chloride. So I'm naming it tris ethane 1,2-diamine cobalt 3 chloride. Easy students? Easy. Let me drink some water. Yes. Next complex, let us see. This is also easy. Calculate X plus. This is neutral ligand 2 into 0 plus NO3 charge is -1. It is -1 is equal to 0. X is equal to +1. Name it. Diamine silver 1 nitrate. Correct students? Easy? Easy. Let us see one more. Yes, let us calculate. This is +1. Then gold is X. Cyano is -1 equal to 0. X is equal to 3. Name it now. It's becoming easy, na students. Potassium tetracyano orate 3 ion or complex. Easy? Easy. So let us see one more. Right. This is again oxalato. It's a bidentate ligand. Correct? How does it look? It looks like this. Oxalato. Name it. Cobalt is X. 3 into -2 to -1, -1, -2, right, is equal to -3. X is equal to 3. Name it. How many are there? Try oxalato cobaltate 3 ion. Correct? Easy students? Easy. Let us see one more. Right. Let us take x. Now let us make it a little bit faster. It is easy now. Minus 2. X is equal to 2. So name is tetracyano nickelate 2 ion. Easy? Okay. One more we will see. It is easy, students, actually. Nothing to worry. So 2 are there. Here, same thing. Chromium 4 into 0 plus 2 into minus 1 plus 1 into minus 1 is equal to 0. X is equal to how much? Name it. Alphabetical order you should do here. Tetra. It is aqua. Dichlorido. Chromium. Then write the Roman number. Then chloride is outside. So it is chloride. Easy, students? Easy? Easy. One more we will see. With this, right? So did we write copper? Chromium tetra aqua dichloro chromium 3 chloride. That's right. One more example we will see. So here, let's check. Here it is X. This is the neutral ligand. 0 plus 2 into minus 1 plus 2 into minus 1 is equal to 0. X is equal to 4. Easy. Name it. Tetraamine chlorido platinum 4 chloride. Easy. See, students, by doing so many examples, it has become so easy for us, correct now? Yes. One more we will see. This is which ligand? This is chelate ligand. And important, it's which ligand? It is a neutral ligand. So the charge is 0 on this. So make it Ni plus 3 into 0 is equal to plus 3. There is a charge here. Write it. Solve it. It is plus 3. So how to name it? Yes, you're right. You should use tris. Because 3 ions bridging, you should always use prefix of bis, tris, tetrakis. Write the name. Elaborate. Ethane 1, 2 diamine. Yes, diamine. Nickel 3 ion. Good, students, easy. Closes. Like that. One more we will see. Easy. Copper. Sino is minus 1. This is minus 2. X is equal to 2. So tetracyano. Yes, students. Tetracyano cuprate, because it is 80 metal ion. And 2, there is an ion. So easy. See here. One more. Here 2 into plus 1. Iron is X. 6 into minus 1. 0. X is equal to plus 4. So name it, students. Name it. So this is copper. Okay, how many cynos are there? Hexa, cyano, ferrate. Correct? Ferrate. Now, this one copper, we'll see copper is stable in +1 or +2 state, no? Right? So for one iron, only one copper ion, so we will take it as 2 complex. Okay, so for one iron, one copper. For 2 irons, 2 copper, but there's only one iron, so I'm going to take this as +2 state. Yes. Now let us see one more. Right, this is which ligand? Neutral ligand. Correct. I'm giving all the combinations, so please check it. Neutral ligand. Name it. X plus 5 into 0 is equal to 0. X is equal to 0. Name it. Penta carbonyl. Yes. Yes. Iron 0. It is 0 complex. Or you can write it as iron pentacarbonyl. Iron pentacarbonyl or 0. Right, like this. Yes. One more we will see. Yes. WC will never leave your hands, students. So remember, always, please share the video. Okay, right. So this is carbonate, correct, my students? This is carbonate. So the charge is -2 plus it is -1, chlorine 0. X is equal to 3. Now name it pentaamine. Pentaamine. What is this complex? Carbanato, correct? And metal ion is cobalt. How much is the charge? 3. What is it ending with? Chloride. Got it, students? Easy? Okay. All right, all right. So one more example. See, this is +2. I don't know this. Thiocyanate is -1 is equal to 0. X is equal to +2. Correct? So let us name this. First is mercury. Okay. How many thiocyanate? Tetra. It is tetra thiocyanate. Okay. It is linking with which atom? S atom. S. So, yes, cobaltate 2 complex. Is it, students? Is it? See. Now, one more example we will see. Okay. This is a bridging ligand and it's a neutral ligand, ethylene diamine. So let's write C. Then 2 into 2 into first I'll write here and then come to chloride plus 0 into 2 into -1 plus -1 is equal to 0. X is equal to 3. Big name, students. So remember, this is bridging ligand. No, how many? Dichloride over. Then I should go to chlorine. No? So and then I should go to ethylene diamine. So bis. What is this? It is nothing but ethane. Correct? 1 comma 2. Okay. Diamine. Okay. Diamine. Then cobalt 3 chloride. Easy? Easy. Okay, easy, easy, easy. Let's see one more. There are two different complexes. This is complex A, this is complex B. So what you should do, calculate separately for both. Separately. So one is cationic ligand, this cationic complex. So cationic complex. So check the first one, students. First complex, this one, what is it? X plus neutral ligand is 2 into 0 is equal to 0. This is for which one? AgNH3 taken twice. Second comes your anionic complex. Okay, anionic complex, and you want to write it as X plus 2 into -1 is equal to 0. This is for the second complex. So what do you get? You get an average. So take an average of both. Take an average of both. Here how much did I get? 0. Here how much did I get? -2. So I've taken average 0 plus 2 by 2. Yes, 0 plus 2 by 2. It's nothing but 1. Correct. So name the compound now. Name the compound. It is diamine, silver, 1 dicyano argentate, silver, dicyanoargentate. So again it is 1. So basically 1, 1. That's you have to write the things as 2 separate. Last but not the least, let us see, students. Let us see. Okay, this is a bridging ligand. So both are in the trans position. This and this is in the trans position. So name it as trans bis ethane 1 comma 2 diamine. Okay, then dinitrito N. Metal atom is cobalt. If I calculate the oxidation state, it is 3. Okay, right. Wow, so many examples. Right. So thank you so much for watching, students. Thank you so much for watching. So one important request, students, always WC has done 1600 plus videos for 10th, 11th, 12th, JEE as well as NEET students. All right, so please watch the complete video. Please like the video, share the video, and my request, subscribe to the channel. Subscribe. WOC provides always free and quality education, students. Remember that. Okay, right? So I'll be coming up with one more important video. Thank you so much. Bye bye. Take care and sign out. Thank you.